Hello children, today we will be starting atomic structure and chemical bonding. We will do the atomic structure today. We will cover the topic structure of atom, mass number, atomic number, isotopes and octet rule. First we will be discussing the definition of an atom, then constituents of an atom, electronic distribution in the orbits following the 2n square rule, definition and examples of isotopes. Now what is an atom? There was many attempts made to know as to what is the ultimate particle of matter. Idea of the smallest unit of matter was first given by Maharishi Kannad in the 16th century BC in India. He said that matter consisted of indestructible minute particles which are called paramanus. Param means ultimate and anu means particle, which is now called atom. Now this Paramanu does not exist in free state, rather it combines with other Paramanus to form a bigger particle called anu, which is known as molecule. Then followed by Greek philosopher Democritus called the Paramanu an atom. Then the first scientific theory was given by John Dalton in 1808. There he said that matter consists of very small and indivisible particles called atoms. These cannot be created nor be destroyed. Atoms of an element are alike in all respects. Atoms of an element combine in small numbers to form molecules. And atoms of one element combine with atoms of another element in a simple ratio to form molecules of compounds. Atoms are the smallest unit of matter that can take part in a chemical reaction. So, the definition of atom can be given as an atom is the smallest particle of an element that exhibits all the properties of that element. It may or may not exist independently but takes part in the chemical reaction. And in other words, you can say that atom is the smallest possible unit of the element. If you take a small piece of zinc and grind it into smaller pieces, all these pieces will show the same properties of zinc. If you grind them further, they break up into very fine particles which still show the properties of zinc. After all, there comes a stage when the particles cannot be further subdivided into particles exhibiting properties of zinc. So these indivisible particles are the atoms of zinc. So what are the constituents of an atom? It has nucleus inside and there are orbits where the electrons revolve around the nucleus. It's the basic structure of an atom where you are having proton and neutron in the nucleus, and surrounding the nucleus there are orbits where electrons revolve around the nucleus. So atom is built up of a number of subatomic particles. Modern theory says that about 200 subatomic particles like positron, neutrino, etc. are present. But out of this, three important subatomic particles are electron, proton and neutron. Now electron was first discovered by J.J. Thomson. Goldstein, a German scientist, he discovered proton, which is a positively charged particle of an atom, and James Chadwick discovered neutron. And these electrons, protons and neutrons, these are called the fundamental particles of an atom, and these particles are the building blocks of all atoms of an element. Now, the three subatomic particles of great importance in understanding the structure of an atom are electrons, protons and neutrons. Now, the properties of electron, protons and neutrons are given over here in the table. So there are two structural parts of an atom, the nucleus and the empty space. in which there are imaginary path called orbit or shells or energy levels. The electrons revolve round the nucleus of an atom along this imaginary path. Protons and neutrons are collectively called neutron, and these are found in the central part of the nucleus of an atom. Now, since proton is having +1 charge, that is positive charge, and neutron is neutral, the nucleus is having positive charge. Now, these are the orbits or shells shown, or these are also called energy level. So, if you see this atom, this is an atom of potassium. The electrons are revolving around the nucleus of the potassium, and this is the innermost shell or the first shell, which is the closest to the nucleus, and this is the outermost shell, or it is also called the valence shell. Now, this figure shows the number of level of the shell. N is equal to 1, N is equal to 2, N is equal to 3. Likewise, some 7 shells are shown. Now, once you come from inside to outside, the energy is increasing. Here it is shown, the energy levels are shown. Energy is increasing from inside to outside. So, the atom has to absorb energy if it has to move from inner shell to outermost shell. And when outermost shell to innermost shell it is going, so the atoms will emit the energy. Now, the different energy shells are shown over here. E1 is having the least energy, that, and then E2, then E3, then E4. Now, here the shells are mentioned. N is the small n is the number of the shell. Let's say K shell is the first shell, so N is equal to 1. Then L shell is the second shell, so it should be N is equal to 2, not 3. Then M shell, N is equal to 3, and likewise. And the energy increases from internal to outside. Now, this is the constituents of atom, mass number and atomic number. Now, what is, if you write the chemical symbol, this is the X is the chemical symbol of an element. This is the mass number, present as superscript, and this is the atomic number, which is equal to number of proton. Mass number is equal to, it is depicted by A, and atomic number is given by Z. So, mass number is equal to atomic number plus neutron. Atomic number is equal to number of proton, and this is the chemical symbol. Let's see an example. It is helium, symbol of helium element. This is the mass number. Mass number is equal to proton, number of proton plus number of neutron. Now, number of proton is equal to atomic number. So, we can find out the number of neutron, like 4 minus 2. So, number of neutron will be 2. More elaborately it is shown. Carbon 2 isotopes are shown. We will discuss isotopes soon. Carbon 12 and carbon 13 isotopes. These are shown as atomic number, and these are shown as mass number. There are several nomenclature to write this, but generally we will follow this one, where mass number will be shown as the superscript and atomic number will be shown as the subscript and on the left hand side. So, number of neutron plus number of proton is equal to mass number. This is the basic relation. Now, let's say this one. Now, this mass number in some book it is also written as atomic mass. So, if the number of proton is 6 and neutron is 6, so atomic mass will be 12. And we know, because the atom is neutral, number of protons should be equal to number of electron. So, if in carbon proton is equal to 6, then electron will also be equal to 6. Now, atomic mass is 12. So, neutron will be 12 minus proton, that is 12 minus 6 is equal to 6. Now, we will go to electronic distribution in the orbits following the 2n square rule, octet rule, etc. Now, distribution of electrons in different shells is called electronic configuration. This was first mentioned by Bohr and Bury. So, these are also called Bohr-Bury scheme. So, let's say maximum possible number of electrons. First rule is maximum possible number of electrons in a particular shell is given by the formula 2n square, where n being the serial number of the shell. Now, this will be equal to 2. Misprint is there. Now, this is nucleus. Then next shell is K shell, where serial number of the shell is equal to 1. Then L shell, serial number will be 2. Then M shell, serial number is 3. And then N shell, serial number is 4. Now, the calculation is mentioned over here. First shell or K shell, n is equal to 1. So, maximum electron will be 2n square is equal to 2. For L shell, it is equal to 8. 2 into 2 square. N is equal to 2. Third shell, n is equal to 3. So, it is 18. Fourth shell, n is equal to 4. So, maximum electron is 2n square, and that is 32. Now, this is the maximum electron number which each shell can count. Now, you can have less than these electrons. It's not mandatory that you should have 18, you should have 8 in respective shells. Now, the energy of the shell increases from K to N, and K is the closest shell to the nucleus. Next rule is electrons are not accommodated in a given shell unless the inner shells are filled. So, the shells are filled up in a stepwise manner. So, first you have to fill the inner shells. Then you have to go to the next shells. Third point, the outermost shell of an atom cannot accommodate more than 8 electrons, even though its capacity is more. In case of calcium, it has 20 electrons. Its distribution in shells is 2, 8, 8, 2. So, now here it is happening like that. You will see soon in the next slide that what is happening post argon. Now, here the atomic number is 20, means proton is 20. Considering the electrical neutrality, electron should also be 20 for the case of calcium. So, the distribution is like this. K shell is having 2, L shell is having 8, M shell is having 8, and N shell it is 2. Then fourth rule, the outermost shell of a chemically stable atom can accommodate a maximum of 8 electrons. Now, in case of calcium, when it becomes calcium plus 2, that means when these 2 electrons are being given to some other atom, for in case of bonding we will see, this becomes stable. Ca plus 2 is stable because in that case Ca plus 2, M is the outermost shell. This shell is not there in Ca plus 2 ion. So, the outermost shell of a chemically stable atom can accommodate a maximum of 8 electrons, except helium atom, which has only one shell, that is K shell, and it can accommodate only 2 electrons. Now, this is an example given for magnesium, where it has atomic number 12 and mass number 24. Now, atomic number is equal to number of proton. To maintain the electrical neutrality, proton is equal to number of electron. So, total electron in magnesium is 12. Now, number of neutron will be mass number minus atomic number, that is 12. Now, in that case, the distribution will be K shell 2, L shell 8 and M shell 2. So, this electronic configuration will be 2, 8, 2. You have to write this way. It's not mandatory to write KLM282, you have to write this way. Now, if magnesium forms iron, that is Mg plus 2, that is it loses last 2 electrons, that is from M shell it loses 2 electrons. So, it becomes stable. In that case, L will be the outermost shell. So, electrons will be lost from M shell. So its configuration will be 2 8. Then these are some arrangement of electrons in atoms of elements given from 1 to 2. You can see this. You yourself practice this. And you have to remember from 1 to 20. These are the orbital diagram shown. Now, in the previous slide, this one, you can see till argon. Argon atomic number is 18 and mass number is 40. So, neutron is 22. Its distribution is 2, 8, 8. Now, post argon, the fourth shell starts. So, below argon, there are the 3 shells and 4 shells starts from after argon, though third shell is full with maximum capacity. So, till argon, each inner shell is completed first. That is, argon is KLM, so 288. Then any outer shell is occupied. For elements heavier than argon, the situation is little different. Third shell M actually can occupy 18 electrons because its maximum occupancy is 18 as per the 2n square rule. But fourth shell starts even though the M shell doesn't have 8 electrons. So, in case of potassium and calcium, we can find the electronic configuration as 2, 8, 8, 1, and calcium it is 2, 8, 8, 2. Now, the valencies are shown over here. The valence shell is the outermost shell. In case of valence shell, hydrogen, the K shell is the only shell, and in case of helium also it is the only shell. So, in this case, K shell, the valence electron is equal to 1, and in case of 2, the maximum occupancy is 2, so its valency is 0. Noble gases, they are having no valency. So, similarly, you have to find out the valence shell. The last shell is the valence shell. These are the valencies. So, we will discuss the valency in detail in next slides. Next, you are having isotopes. So, isotopes are the atoms which are having the same atomic number but different mass number. As per syllabus, you have hydrogen, carbon and chlorine. So, first we will see the hydrogen. Hydrogen is having 3 isotopes: protium, deuterium and tritium. So, deuterium is called heavy hydrogen also. They are having same atomic number, that is 1, but different mass number 1, 2 and 3 respectively. So, now isotopes differ only in their number of neutron. Protium has no neutron, deuterium has 1 and tritium has 2 neutrons. From the symbol itself, you can get 1 minus 1, that is mass number, this is atomic number, no neutron, this is 1 neutron and 2 neutron. Then come to the carbon. Carbon is symbols are 12, 6, 13, 6 and 14, 6. This is the abundant one, 98.9%, carbon 13 is 1.1% and this is the least amount is found. Now, this is carbon number, neutron you can find out, mass number minus atomic number, that is 6. So, the isotopes vary in neutron numbers. Now, comes to the isotopes and relative atomic mass of chlorine. So, isotopes are atoms of the same element that have different number of neutron. Now, chlorine has 2 isotopes, 3517 and 3717. So, you can see the variation, 17 electrons, 17 proton and 37 minus 17, that is 20 neutrons. Here also 17 electrons, 17 proton and 35 minus 17, that is 18 neutron. Now, abundance of 3517 chlorine is 75% and abundance of 3717 chlorine is 25%. So the relative atomic mass of this chlorine is the average value for the isotopes of the element. So atomic mass is coming as 35.5. It is a fraction. But in case of mass number, it is not at all fraction. So the relative atomic mass is calculated as 35, that is a mass number of 3517 chlorine into 75% plus 37 into 25%. It will come as 35.5. So these are certain figures used from different websites. Thank you for your patience hearing.